you enjoyed. We are diving into the next innovation showcase. We already heard from folks working in K-12, and now it's time to hear from folks in the higher education sector. Our first presenter kicking off this innovation showcase is from OpenStax.
Great, thank you. Thank you so much for having us today. This reminds me of a very early OER conference, Open Ed, where there were about, I think, 80 people in attendance. That was like 10 years ago. Now they have 1,000 people every year. So it's a great experience. So what I want to do today is talk about OpenStax and the dynamic ecosystem that is being built up around it. And there are many benefits to this ecosystem that we will review. But first, a brief introduction. What is OpenStax? We're a non-profit publisher based out of Rice University, and all the resources we produce carry a CC BY license, meaning that you are free to take them, adapt them, and distribute as you see fit. We professionally produce resources. We currently have 47 openly licensed textbooks in the library, and they meet the scope and sequence of most courses. So what's the impact of this? We have over 5.9 million students using these resources this year. It's tremendous. And then that's due to the great network of institutions that we work with and faculty. We save students over $1.7 billion. They're used in 139 countries, and 68% of US colleges use OpenStax resources. So the impact is tremendous and growing. So what were the goals of the ecosystem that we built up around OpenStax and OER? We had three major challenges we had to address. One was driving awareness. As a non-profit publisher, we didn't have any sales force. You could argue we were definitely not a vendor. We would have to partner with institutions to drive adoption and awareness of these resources. If you build it, they don't always come, we can guarantee that. Second, we wanted to foster innovation in the higher education space, especially regarding technology. The market has become very stagnated, and there was not a lot of innovation because it was controlled by three principal companies. And so we wanted to have a way to drive innovation. And of course, we wanted to enhance affordability for students. When we started OpenStax over 10 years ago now, the price of textbooks were getting higher and higher and higher. In fact, the price of an organic chemistry book or an anatomy and physiology book went north of $250. And if you're a struggling community college student, or any student for that matter, that is nearly impossible to overcome. So what is the basic mechanics of the OpenStax marketplace? The first thing is an ecosystem of partners that provides a mission support fee back to OpenStax to help us maintain the library. So they sell a good or a service around what our content. They will provide a mission support fee back to us, and that helps us maintain the library. So when you're giving away a free textbook, or a whole library of textbooks to students and resources, you need a way to maintain it. Our great supporters and foundation partners understand that that you cannot just develop them without mission support fees. Next, ecosystem partners may use OpenStax logos and brand markets. Why is this important? When we started OpenStax, we wanted to go to a lot of traditional players in the market that had the network to drive awareness for us. But now it's actually reversed. A lot of new organizations into the market and ed tech developers, they want to be able to leverage our network to build awareness for their brands. Third, we are responsible for the content maintenance and updates of the resources. So in a lot of markets now in higher education, pedagogy advances, content changes, etc. And so you must keep the resources current. And that's what we're responsible to our ecosystem partners, so that they no longer have to worry about maintenance of content. And that saves them a tremendous amount of labor and resources. Fifth, co-marketing. We co-market with our ecosystem partners so that they can be introduced to our network, they can introduce us to their network too. And this is a great cycle, virtuous cycle, because it builds awareness around solutions that are not just the traditional solutions controlled by three entities. And that leads to the last point, and that is access to the community of users. So, what are the results of this? We have a marketplace now supporting choice. We have over 56 ecosystem partners. And some of these may actually surprise you. Cengage Learning is actually an ecosystem partner. They have a platform called WebAssign, and they've got one called OWL, and they have ingested our resources, and they provide that to the community. And what I find fascinating is that offering they sell at about a 50% discount off the same resource that they offer utilizing their proprietary content. So that is a great savings for students. And then there are great innovators too in the space that are utilizing our network and our content. One of them has been used pretty extensively at ASU called Cogbooks. So the ecosystem partners are very varied and growing. These are just a few examples of some innovators. Expert TA, Newton Alter, which is an adaptive learning platform, Zybooks, which is for computer science. So what is the result of this on a macro market basis? 49 out of 56 ecosystem partners offer subscriptions for less than $40. In the post-secondary space, the traditional publishers, if you go and get their subscription for their courseware, most likely, it's about $125. So you can see a big differential there. And across the entire landscape where we publish in now, according to AEI, for the first time, really in a generation, the price of course materials have actually come down for students. And we don't just mean the textbook, we mean interactive content, digital subscriptions, etc. So this is having a permanent and lasting effect on distribution throughout the market. So some additional results from the ecosystem partnership. It's accelerated the use and the development of innovative courseware. If we were going to go back 10 years, and some days I'd like to, we would not have as many, there would be very, very few disruptors in the place, in this space. And the major reason is because they didn't have access to content and assessments that they could populate in their platforms. It was the barrier to use those materials were too great. The maintenance of the library is fully self-funding. So now we maintain the library, we're not relying on grants, we do revisions, we do annual updates. In fact, it was one of the things that our competitors, actually Cengage at the time, said, oh, they'll never be able to keep the library up to date. They were wrong on that. The network effect to drive growth. And so what we've seen, especially post-COVID, is because now we're in so many institutions and we work across so many partners, the awareness of OER and OpenStax has grown exponentially. In fact, the customer acquisition cost, if you look at it on a student basis, is really, it's pennies on the dollar compared to what a traditional publisher would do. And that is one of the key virtues of that open license. Could really call it an innovator license. And then there's opportunities to engage in research to improve learning outcomes. This is very important. Make no doubt about it, OpenStax we've been able to scale because we are distribution reform and access reform. To date, we've not really been pedagogical reform, but we're seeing now that the market are taking materials and now starting to drive pedagogical reform through use of flipped classrooms, etc. So I think these are very, very exciting additional results. So where can we go with this vibrant marketplace? We see OpenStax as becoming an EdTech hub of innovation. So more and more EdTech providers come in As a user, as a faculty member, or as an institution, you can self-select what your key criteria around access, learning competencies, outcomes, focus on DEI, many different criteria, and then make recommendations to you, and so that you can best pick the solutions that meet your curricular requirements. At the end of the day, this is about choice, not about control. Dynamic and personalized solutions for faculty and students. Increasingly, that personalization, not one size fits all, is very important. Data-driven innovation. We can use data to improve not only the content, but the resources. This is a very tricky one, though, because it requires a shared ownership mindset of the customer, if you will. This whole system doesn't work if you believe in control. I've got to control the IP, I've got to control all the data. This is a shared system where we share information back and forth, and that's how we can improve. So I would say if there's any requirements to be part of an ecosystem like this, is that you're willing to share with the ecosystem. And then I think there are enhanced opportunities for disruptors, the real innovators in the space, because they can tap into the scale of the ecosystem to drive awareness of their resources. And I think that's very exciting, and will usher in an age in which the walls to disruptors are actually lowered. It's still going to be difficult, there's no question about that, but it's going to be significantly easier. Thank you very much for your time.
For your presentation. Up next is Dreamscape Learning.
Thank you, David. I was an early adopter of OpenStax. I was using it in the classroom in 2015, which is pretty close to the beginning, and I think it's fantastic. And I think it's fantastic because it saves students a lot of money on a product that I think nowadays we'd agree we could open up our phone and get a lot of that information for free anyway, so an organized free way is great. But I'm still left with this problem. How do I get my students to read that book, even if it's free? And this is a problem I struggle with throughout my career, and I'm sure many here who have ever taught before had this problem. And if we can't solve this problem, we're left with an even bigger problem. And this is, from my perspective, what I think about the most concrete way of visualizing this problem is to say that 45% of our majors in biology, where I'm a professor, leave after 1 year or before 1 year. And I think that reflects roughly, now that ASU is doing a poor job, that's pretty much nationally what's happening in STEM degree programs overall. And so what is causing this? I think one of the problems, many things can cause this, but one of the things that I realized is as a professional biologist, I don't use most of what I learned as an undergraduate. And yet I'm a very successful professional biologist. I never received as a student a compelling and immediate need to know any of the crap that my professors were asking me to learn in a very brief period of time. Instead, I have a very small toolkit of generalizable, transferable skills that I use to learn on the fly to solve problems that biologists solve. And I think this is the way to think about education in all of STEM for the future, to bring a balance between the concepts we want students to master and the skills we want them to have, and give them opportunities to apply both those concepts and skills in very realistic situations, to work together in teams, to solve problems, to quantitatively reason, and do all the things that make me and other biologists and scientists successful in what we do. So at ASU here, we're trying to do a couple of things to improve that situation. And one, we're trying to engage our students in solving realistic problems from day one in the mindset that they are biologists. We don't ask them to learn everything that biologists have done. We ask them to become biologists and solve very concrete problems that we've designed, engineered for their level to accomplish certain things that they need to do in a learning progression. And then we support this learning progression with an adaptive curriculum. And we use OpenStax, actually, in some of that adaptive curriculum and a product called Cogbooks, which allows us to assess where students are at in their trajectory and provide them with the right lessons, activities, and feedback that they need at that moment to progress. I'm going to show you a video of how we engage students. So in the past, I would have sat, like many of you sat in the classroom, and listened to someone talk about how cells work in order to learn cell biology. Instead, through Dreamscape Learn, We will put them into virtual reality, and they will see this before coming to class.
Welcome back to the Intergalactic Wildlife Sanctuary. A fundamental question that the Intergalactic Wildlife Federation faces in our sanctuaries is when to allow the natural rhythms of life and death to proceed unabated, and when to prevent the extinction of a species. As we did with the Astrolabes, today we face this very question with another species. This is a Paromystide, or spotted glider. Gliders play a key role in the ecology of the Elorian forest. By eating the fruits of umbrella trees, they spread the seeds across the forest floor, enabling the trees to disperse. Over the last few days, our monitor drones have detected a marked increase in unexplained glider deaths. We need to understand why.
We need to understand why. We hope that students, whether it's through a 2D simulation or an audiobook or a VR experience, understand that there isn't a problem and become emotionally attached to that problem. There's a specific organism, it's sick. That's why I became a biologist, I like organisms. And I need to know how to solve that problem. And in that journey, we can present them with opportunities to do things that real biologists do, like perform a necropsy, or as you might say, autopsy, and discover these things have tumors. They're riddled with tumors throughout the respiratory tract. Well, what do? Well, how is cancer caused? And so we might learn about the things that cause cancer. We might collect data, and each student gets unique data generated by random statistical models on carcinogens in this case. They learn how to analyze these data and draw conclusions about what might or might not be happening. And through this process, they become explorers in an adventure or in a story to solve a problem and become the heroes. They'll learn that this cancer is actually transmissible. Unlike most cancers on Earth, it's contagious. Cells from one spotted glider, these creatures, pass to another spotted glider through the respiratory tract, and their social behavior transmits this. They'll do DNA sequencing to figure out that, in fact, the cells are genetically identical and come from a source. They'll then explore through cell biology, applying all the concepts you might learn normally in a class, like proteins and cells and signaling between cells by proteins, to decode this cancerous pathway. And then in doing so, they'll have to learn about how proteins bind so they can figure out what malfunctions in the cells cause these cells to grow undivided, so are controllable. And in the process then, they'll think about how they might develop a treatment. And they'll build a virus that binds specifically to receptors on the surface of these tumor cells, but not on healthy cells. This whole journey will require them to learn the same concepts and skills we want them to learn anyway, but it's a hell of a lot more exciting and interesting to students. And in the end, we'll know that they learned, because not only will we just have pre-post tests on this, we'll also then present them with a novel, analogous case that happens on Earth. So if you really understand how cells work, and you can really figure out how to design a treatment for cancer, you should be able to solve an analogous problem, either with cancer on Earth, or even a farther transfer, that gastric ulcers are caused by a very similar problem with the cell signaling pathway, and you can engineer a drug in the same way to fix that problem and cure gastric ulcers. So these are the kinds of ways we give students opportunities to encounter interesting problems to solve, practice application of what they're learning, and get feedback on this, and each time in a novel way so that they know they're actually progressing in their skills. We pilot tested this now last year with about 100 students in a one-day thing, and these students made an 18% gain in high Bloom's level questions on a pre-post test about food webs and the ecology of food webs. It was a different scenario than I showed you today. We're currently testing this in the classroom with 750 students in both non-majors and majors biology course. And we've done a randomized replicated trial. So we have 30 lab sections. Half of them are doing the traditional curriculum. Half of them are doing the new Dreamscape learning curriculum. They're at the same times, with the same lecture instructors, same campus shells, except the students were randomly assigned to one of these two treatments. And so by the end of this semester, we'll know exactly how much better they learned. Maybe in some ways they'll learn better, in other ways they won't. And we'll even know who benefits the most from this kind of learning. And there's all kinds of information we have coming out, not just do they learn to master the skills, but are they emotionally engaged? And so in our initial surveys, we see things like students are surprised, they're amazed, they're even afraid and sad because there are jump scares, and then there are moments where organisms are sick. And all these emotions help to codify things in long-term memory. We also assess things like cognitive engagements. We find that the vast majority of students believe they're actually learning. They understand why they're doing these things. These students prefer to do it in VR. They would do it again this way, and they would rather do this than just sit and listen to me talk like I'm doing right now. So we're going to hopefully see that this is working in the classroom, and if so, expand this to other courses. The next course on the docket is Climate Science and Sustainability. Essentially, how do we solve the world's problems that we have on the global scale? So imagine you now work for the Earth League, and in secret cahoots you work with the Institute for Time Travel. And you can go back and try to understand and correct things that were happening on our planet. Maybe learn about and figure out how to solve some of the problems we deal with, and how to apply that to real life decisions. We're also looking at ways to deliver this more than just online or at scale in large classrooms or labs, but how to deliver this in special ways. So just imagine this was a whole classroom with VR goggles right at your station. And what we would do is we would go into virtual reality, and I would be a teacher. That I would meet you in there and physically have an avatar. And we might walk around the cell, and I would talk about things and ask you questions about it. Or we can go to an archaeological site together if it's not a biology course. Or we can go to an art museum. All of this will be possible through Dreamscape Learn. And then finally, we hope that these products, excuse me, I clicked too fast. These products and the technology itself will be marketed at scale globally. So it will be available for you if you work for another institution to adopt one module, one course, or the whole idea of teaching in this way. So thank you very much, and I turn it over.
All right, thank you very much. Our next presenter is from Minerva.
Hi, thank you. I'm Noah. Sorry? Clicker. I'm Noah Pickus. I'm the Chief Academic Officer at the Minerva Project, which I came to after 25 years at Duke University. And one of the reasons I joined Minerva is because since about 2015, I've been coming out here to ASU about twice a year to see the future, which we just saw. And I want to talk to you a little bit today about what we're doing at Minerva Project, and to have my colleague James Genone take you through some of the problems we're trying to solve. So it's exciting to be in a group like this here at ASU, because we all know the answers to this. We can all imagine this together. What does the future look like that would be high quality education? Well, it would be based on the learning sciences. It would be rooted in the fundamental research we know about the best pedagogical practices, and they would be put into place. Every institution would have the commitment and the capacity to actually do that, not do it on the side, but to do it as the center of what they're doing. And those institutions would be networked, they'd be connected, they'd be in an open learning kind of ecology in which they could iterate, validate, and innovate. It's not hard for us in this room to imagine what that future looks like. And we can imagine the benefits that come from this as well, right? Improved learning outcomes, closing the skills gap, greater employability. We could have not only all of those, we could have lower costs, and we could have maybe even wiser and more informed and better citizens. So there's a lot that we can imagine right now that we already know together. We also, I suspect, let's see. I don't know. I'm going to let you see if you can sort that out while I suspect. We also know what the problems are, right? I mean, let's be clear about this. What Michael Crow said this morning is that for all the importance of technology, the fundamental challenges that we face are institutional commitment and institutional alignment. The ability to work not only with technology but learning science to make a significant difference. See if they're getting it out. And the problems there are also well known to us, right? The market in higher education, driven not primarily by market signals but by prestige. which drives an institutional isomorphism, a imitative approach in which one institution always tries to look like the other institution, right? There are the problems inside institutions where the incentives are misaligned, right? Where you've got so many different commitments from so many multiple missions and stakeholders at most universities that it's very hard to bring that direction and focus to bear that we imagined just a few minutes ago. And you've got, and then of course you've got the fact that we don't have networks. We have this wonderful but maddening decentralized system in higher education, which is full of institutional siloing, right? Where one institution learns something, does something, and there's no connection that travels over to other institutions. It's a remarkable and maddening kind of system. So my colleague here, James, is going to talk to us a little bit about how you address that fundamental question of building institutional capacity to accelerate at speed the kind of changes that we need.
Thanks, Noah. So I'm James Genone, and I was really glad that our presentation came right after Michael in Dreamscape because, as Noah said, the challenge that we're trying to address is how do you drive the adoption of these kinds of evidence-based, innovative, technology-enabled practices at scale. And that's what we've been focused on through our partnerships. And we've been doing that in a couple of very specific ways. So the first is to, again, sort of build on what Michael was saying, engage students. And we do that by building a bridge between the traditional academic classroom and hands-on, applied, experiential learning. We're integrating those things. So all of our programs and the programs that we enable have these internship, employer partnership, applied, design-oriented learning experiences for students, which go along with the academic learning that they're doing. Second, they're interdisciplinary. So we've heard about transferable skills. We believe that that's the key ingredient, and it's the deliberate spaced practice, it's the repetition of the application of those skills across contexts, across domains, that enables students to get beyond the sort of more narrow disciplinary knowledge they tend to acquire in their majors and prepare them for the world of employment beyond. And then finally, the trend that was emerging before COVID and has been massively accelerated by it is the use of technology to allow this kind of learning to occur across modalities, virtually, synchronously, and asynchronously, in person, but in a coherent and cohesive way where the student learning experience is being tracked, where we're understanding which students are being successful, which ones are falling behind in a comprehensive way so that we can intervene in ways that will drive improved learning outcomes. So we've been doing this over the past several years, and we've started to build up an ecosystem of partnerships. And what's really interesting about, these are just a few of our partners focused primarily in higher education, is the diversity here. These approaches that we're using work for lots of different audiences of students, and they're relevant across regions. And I'm just going to give you one example to give you a sense of what that looks like. So for the past 6 months, we've been working with the University of Miami. And they have a very interesting confluence of circumstances. First of all, there's a technology surge happening in the city of Miami. Second, they're about to hit their centenary in 2025, 100-year anniversary. And they have a visionary president who sees this as a moment where the University of Miami can reinvent itself. So we're working together with him and with their provost to create an innovation incubator within the university. And this is being called the New Century Program, and will eventually become a college. So the provost appointed 12 innovation fellows to work closely with us and to design this new program. And they're from across units and colleges within the university, and that's generated a tremendous amount of buy-in across the campus to this kind of innovation because it's seen as a collaborative effort. And we were gratified to hear from the provost just this week that these innovation fellowships are now one of the most coveted positions for faculty. They're really excited to engage in this kind of work. And the program that's coming out of it, which is now working its way through approvals, and we're very optimistic about it launching this coming fall, it's an interdisciplinary program, again, supported by 3 different colleges within the university. It's on innovation, technology, and design. It's a 3-year accelerated program, so you can all understand what that means in terms of cost and accessibility to students. And it integrates not only all of these interdisciplinary skills, but also this engagement with employers in the city of Miami to help prepare students for jobs. So we believe that some of the key ingredients from this partnership generalize. First of all, there's the alignment with the strategic priorities for the institution to engage with the city of Miami, to innovate, to break out of the traditional program development cycle that they have. There's broad buy-in from across different levels of the institution. So from the senior leadership to administrators who supported the accreditation process and so on, and to faculty. And this is where the partnership has been key, learning from everything we've been able to do in building our own university and working with other partnerships, implementing a lot of these evidence-based practices and technology to make sure that the student experience is cohesive and coherent and integrated. And then using this partnership model to build capacity on the university side, right? We're enabling, again, this incubation of innovation at University of Miami that we believe will expand to other programs there. So I'll hand it back to Noah to just talk about how what we're seeing here, we believe, will have an even bigger impact as this network of partnership grows.
The story here is simple. This is the call to action part. This is what we're all here doing. So often, I loved it how in the curricula setup we were asked to speak to the question not only about collaboration, but about scale and impact. And sometimes when people talk about scale and impact, what they really mean is scale. In other words, the idea is if you're not getting bigger, if you're not becoming a bigger institution, right, then you're not actually having an impact. Now, surely here at ASU, right, becoming bigger has had an enormous impact. But so too has ASU's networking capabilities. And what the slide you saw earlier with this heterogeneous set of institutions, new universities starting in Mexico and Korea, HBCUs in Texas, liberal arts colleges in North Carolina, the goal here is to build a network where you don't have the institutional siloing, where you actually have enough commonality going across the institutions built on that internal capacity that James spoke to, but generating the kind of data and information so that partners want to learn from and improve and actually make education better. And so that you end up with more of a constellation, a network, an ecology, than you end up with the kind of individual siloing which we know so well. That's why we're here, and we're thrilled to be part of it. Thanks.
Thank you very much. Our last higher education presenter for today is from Wize. Let's give it up for them.
It was the summer of 2009. I just finished my first year at McGill University, and I just got my grades back. I was pretty stoked. I did well, and I was headed into second year. That's when my phone rang, and my best friend and college roommate called me. He goes on to say that he failed his calculus course. It was high stakes. He couldn't continue on with his program. I couldn't believe it. I had to find someone to take over his part of the lease. And to my surprise, I quickly Googled just how many students run into the same problem. And as we heard from Dr. Michael Crow earlier today, only about half of college freshmen who start make it to graduation. Albert Einstein once said, everybody's a genius, but if you judge a fish by its ability to climb a tree, it will live its whole life believing that it is stupid. Me and my college roommate and former best friend, we had the same high school teachers, we took the same courses, we entered the same program, and I reflected back and there was one key difference. And that difference was I could support myself, or I could have a private tutor support me with that high stakes calculus course in my first year at university, and he couldn't. And there's 20 million college students across the US for which not everybody has that luxury. So it was in 2012 when I graduated college and I was thinking about the value that I wanted to add to the world, that I decided that I'd go on a mission to make tutoring accessible to every student on the planet and try to positively impact the percentage of freshmen who start college and actually end up graduating. This is a picture that I took back in 2013, and it was my first stab at trying to do just that. Essentially, I would call tutors that were charging upwards of $100 per hour of instruction, and I would convince them that their time was better spent instead of one student at a time, helping students in these things called group review sessions. And instead of them making $100 per hour, I promised them upwards of $300 per hour, all while being able to support students at $10 per hour of instruction. And it was my first stab at making tutoring more accessible. In our first year, I'm not sure if students came for the Costco granola bars that I picked up or for the expert instructions, but in 2013 we helped 100 students, and by 2017 we had put on over 1,000 in-person review sessions across 10 different colleges, and I had worked with hundreds of expert tutors who developed a vast library of evergreen content for 18 different high-stakes subjects like physics and calculus and economics and accounting and so on. In 2017, with our experiences, we felt we were ready to develop the 2.0 version of Wize and scale our approach to the 4,500 colleges across North America, leveraging the power of technology. We worked hard since 2017 to come up with a unique and innovative approach to being able to scale the best tutors and the best evergreen content. And we're supporting students the best we ever have, 24/7, 365, in an on-demand format. The learning experience from a student's perspective on Wize is remarkably simple. They simply go to wizeprep.com, they enter their exact university, they enter their exact course code, and they're provided with micro video lessons that provide them tutorials outside of the class. They're provided with exam-like practice questions, and they benefit from our adaptive learning technology that eliminates their strengths and weaknesses. We created a next-level customized and personalized learning experience, and after 10 years of working with students on the solution that I set out to solve after graduating, making personalized tutoring support more accessible, I can say that we're finally really helping them outside the classroom, and it's all for less than $1 a day. In fact, 98% of the students who used Wize last year indicated they improved their grades, and many of them have referred to us as their guardian angel when they had no other option to help them get through those high-stakes courses. With our new approach, we've already helped 128,000 students across 120 schools in 42 different provinces and states, and as a result of the pandemic, our mission is more important than ever. In fact, this upcoming school year, we're working hard to make sure every student knows about Wize and the value that we can add, and we hope to expand globally thereafter. Although we have predominantly focused on the college sector, this coming September, we'll be expanding our services into the high school space, supporting high school students, as well as this month we'll be launching a program to support students into getting into medical school with a professional program prep course. We recognize that the earlier that we can help students in their academic journey, the more easier they'll be able to thrive through life. And we look forward to engaging with all stakeholders to hopefully one day be able to be part of leveraging longitudinal data and AI to provide a truly personalized learning experience for students from elementary school all the way through corporate learning. Some of our existing partnerships include working with amazing educators who are interested in trying to flip their classroom or who just want to offer a more personalized resource than Khan Academy or YouTube and a more affordable resource compared to private tutoring. We partner with school administration, student groups, fraternities, sororities, even NCAA athletes to get the word out about Wize on campus. And we're exploring partnerships with charities where their donors can opt to donate Wize subscriptions to specific students and receive updates on the impact that Wize has on those students' academic success. And of course, we work with a variety of different companies, but we're extremely excited to be working with Curikey to benefit from some of their remarkable open source learning technology that will help us advance the learning experience our students have on Wize and update our over 4,000 hours of video content to make them a lot more engaging and lean hard into an active learning experience for our students. Our mission is a tall order task. We're not naive to how many stakeholders there are in education, nor are we naive about how much collaboration is going to be needed for us to be able to make a big impact. So first, I want to pay tribute to the amazing work that everyone has done and is doing to support this vast ecosystem, and I want to emphasize that at Wize we look forward to embracing a collaborative approach in order to make the biggest impact we can. I'll leave the stage throwing out two asks to the audience. One, if you're a part of an organization and there's any way that we could collaborate, please reach out. I look forward to connecting. And two, if you're an investor that may be interested in supporting our vision, please reach out as we'll be opening up our next round of funding this spring. Thank you for all taking the time to learn about Wize's mission and what are we up to. And special thanks to Curikey, Arizona State University, and Stand Together for inviting me here to speak today.
Thank you so much to those fantastic presenters. We are now going to take a 5-minute stretch break before our next working session, so you have until 1:48 on the dot to come back and engage with some of your peers. See you in 5 minutes.